All right, so here we're going to answer this question. We're going to approximate the integral of sine from 0 to pi over 2, and we're going to use Simpson's method, but we want to make sure that the approximation is off by less than 0.00001. And we just want to figure out how many partitions do we have to use, or subintervals. So the error, the maximum error that Simpson's method can give you is this value. So the question is really this: when is this maximum error? Or for what value of n is this maximum error going to be less than or equal to 0.00001? So here we go. Pretty easy question. As soon as we can find the maximum derivative, the maximum fourth derivative of sine x, from 0 to pi over 2. So this is a lot easier than you would think because the derivative of sine goes to cosine, then back to sine, then back to cosine. And for both of those functions, from 0 to pi over 2, the maximum they can get is 1. So you can get this without doing any derivatives. There's no way it's going to get higher than 1. We know that from trig. So this max here is going to be 1. And the rest of it now is just plug and chug, basically. So maximum that the fourth derivative sine is going to get is 1. B minus A, our interval is 0 to pi over 2. So it's pi over 2 minus 0 to the fifth. We have 180 times n, which is the number of subintervals that we need. And that's what we're going to solve for. So we're going to figure out what n is so that this error is less than 0.00001. So I'm going to multiply the n to the fourth over here and divide the 0.0001 over here. I think I got all those zeros in. So all I have to do is calculate that, and that will get me the answer. So here goes in the calculator. I'm typing pi over 2 to the fifth. I'm going to divide that answer by 0.00001. And then I'm going to divide that answer by 180. And I got this huge, oh, I see what I did. All right, so we have, that's okay. I thought I did something wrong, but now I have to take the fourth root. So there's my equation. So I'm going to raise my answer to the 1/4 on my calculator. And now I have a reasonable answer of 8.53. And I'm going to stop there because n is the number of intervals. So it's going to be a whole number. So I'm going to say we should use 9 intervals. N must be greater than 8.53. So we should use 9 intervals to get the error that we want. Hopefully you followed that. And that's all there is to it.